In this video, I want to talk about the cumulative density function, abbreviated by CDF. I'm going to let capital X be my particular random variable that I'm considering. The cumulative density function gives the probability of events of the form capital X less than or equal to little x for all numbers x, for all numbers little x. So the idea is it tells you what proportion of things came before. It's typically denoted by a capital F and is the probability that capital X is less than or equal to little x. So I'm going to discuss some basic properties of this function, and then I'll do several examples of cumulative density functions. The first thing, if A is less than or equal to B, then capital F of A is less than or equal to capital F of B. This should make sense since, like I said, this capital F is really telling you the proportion of things that came before that. Since A is smaller, there are fewer things before A than B. So the probability that you came before A would be smaller than the probability that you came before B. Next, f of minus infinity is 0 and f of positive infinity is 1. Since we're looking at the proportion of things that came before, nothing comes before negative infinity, so that probability would be 0. Everything comes before infinity, so that probability should be 1. Finally, if A is less than B, then the probability that X is between A and B, including B but not A, is equal to capital F of B minus capital F of A. So the capital F of B tells me everything that is less than or equal to B. This would be everything that's less than or equal to A. So I'm going to take everything that's less than or equal to B, subtract out the stuff I don't want, and that'll get me the probability that X is between A and B. So let's look at some examples. Here I have a PMF of a particular probability distribution, and I want to find the CDF, the cumulative density function. Well, we can see that 1 is the smallest thing here, so we know that f of x, we're going to have several pieces here, it's 0 if x is less than 1. Since nothing comes before 1, the probability would come before 1 is 0. The next probability we have is 0.4. The CDF tells you everything that comes before it, so this is going to be between 1 but still less than 2, since once we hit 2 we're going to add in some more pieces. When we reach 2, we're considering once again everything before it, so we have a total of 0.7. And this is for 2, but not quite to 3. We then add in another 0.2 to get to 0.9. And that's going to be up to this 0.4. Adding in the last piece of 1, this is going to be for everything greater than 4. So this right here is what my CDF looks like. This is a function for discrete distributions. It will be a step function like this. So let's look at another example. Here I have another PMF, and once again, I want to find the CDF. This time I'm going to have this general function. My lowest value is 0, so everything that comes before 0 has a probability of 0. The probability that it's equal to -1, -2, -5.7 will all be 0. My next value is 0.05. And now this occurs when we hit 0, and when we get really close to 1, our next value. We now need to add in 0.1, so 0.05 plus 0.1 is 0.15. This occurs when x hits the value of 1 up until right before it hits 2. We then add in our next value, so 0.15 plus 0.15 is 0.3. This is going to happen once we hit 2 and right up into our next value, which is 3. We then add in a 0.25. This gets me to 0.55. That happens at 3 up until we get really close to 4. We can then add in 0.35 to get 0.9. That happens when we hit 4 and we get really close to 5. And then finally, once we hit 5, our value will just be 1. Since nothing comes greater than 5, we just have that x is greater than 5, the probability would be equal to 1. I now want to use this cumulative density function to find the probability that x is between 1 and 4. So I'm going to do this by starting with the 4 value. And that's going to occur here. So that would be 0.9. Well, this right here tells me the probability that x is less than or equal to 4. So this gives me extra information. So I need to subtract out what I have extra. Well, I want to include everything through 1. So through this value here. So I'm going to subtract out and remove this probability, 0.05. This is the probability that x is strictly less than 1. So that gives me 0.85. And we can double check this. 0.1 plus 0.15 is 0.25, plus 0.25 is 0.5, plus 0.35 is 0.85, which is exactly what we wanted. For my next example, here I have a cumulative density function, and I want to use this to find the probability that x is greater than or equal to 2. Well, this is actually going to be hard from this particular function, so instead, whenever we want a greater than, using our cumulative density function, we're going to do 1 minus the opposite. I'm going to do the probability that x is smaller than 2. Well, that would be right here. This is where x is smaller than 2. So 1 minus 0.7, or 0.3. I can also use this to figure out what my probability mass function is, what my PMF is. We're going to use these values here to figure out what the top row should be. So my cutoffs in my piecewise function are 0, 1, 2, and 3. Between 0 and 1, I get 0.2, so that would be my first value. For 1, 0.2 plus that value is equal to 0.7. So we get 0.5, so that this adds to 0.7. 0.7 plus my next value should be 0.9. So that one would be 0.2. Since 0.7 plus 0.2 is 0.9. Finally, to get from 0.9 to 1, we need to add 0.1. So these values here, the 0.2, 0.5, 0.2, and 0.1, this would be my probability mass function.